Electromagnetic waves are one of the greatest miracles in the universe. We go ahead with our part 2 of our wave propagation tutorial. After the short range that we covered in part 1, we are covering now the mid-range. As usual, I'm trying to make things easy to understand. And of course, there will be spreadsheets that can predict wireless range. In our part 1, we were talking about some theory about wave propagation, and we looked at a few examples for the short range from 0 to 1 kilometer. In our part 2, we want to tackle what we call the mid-range, which is between 1 kilometer and 20 kilometers. In addition to this, we need to talk about the signal and interference statistics. Now, let's talk about the wave propagation prediction in the mid-range. Here is a famous method that is also implemented in many professional tools. I need to mention that the method usually only makes sense if one part of the system is on a higher level above ground. Let's call this a base station, which might be located on a hill or a tall building. The opposite part we call a mobile station that can be everywhere in the field. We talk about the so-called Hata Okumura model, regards to my friends in Japan, which is practically a functional approximation derived from measurements. We call this also a heuristic model. It is able to consider different land usage. However, it is restricted to the antenna heights and frequencies that have been measured. We can use it for base station heights from 30 to 200 meters and the mobile station heights from 1 meter to 10 meters. The frequency is restricted to be within 150 to 2000 MHz. Of course, we have implemented this model as well in our spreadsheet tool. I think an interesting example for this model would be a LoRa local area network with a central base station or gateway and a number of sensor devices in the field. Let us assume an example with a base station height of 25 meters. The frequency shall be 866 MHz. The transmit power shall be 14 dBm, which is the maximum allowed value in Europe. Furthermore, let's assume an agricultural area. The Hata correction factor is -12 dBm therefore. As a prediction result, we would get here a decent coverage within a range up to 1.7 kilometer for sensor devices in 1 meter's height. Of course, we can play with all the parameters here. And for example, for the mobiles at 3 meters height, we would get about 2.5 kilometers range. Why are we always talking about several dBs more than the receiver's sensitivity for a decent radio connection? This is for two good reasons. A, because radio signals are volatile, and B, for digital systems, The receiver sensitivity is defined as the level where the bit error rate is 50%. When we predict or measure the received signal strength, we always talk about the so-called median value. The volatility of the signals we describe by the so-called standard deviation sigma, which is typically in the range between 3 and 8 dB in the case of our radio signals here. In our example graphics, we see a receiver sensitivity of -118 dBm, which corresponds then of course to a 50% coverage probability at the receiver sensitivity level. Practically, this means roughly a 50% success rate in the reception of our data packages. However, usually a decent radio link should be better than 90% success rate here. From our graphics we can derive that we would need at least 8 dB more received power for this. With that, we can now calculate the coverage probability for any predicted or measured field strength. We can roughly assume sigma to be less than 6 dB for fixed systems and more than 6 dB for mobile systems. And just as a hint here, we have seen in a previous video how to compute the median values as well as the standard deviation from measurements. Of course, we have implemented the signal statistics on our tool. We choose the set sheet and then we can do an example. And again, we choose the LoRa example because we were talking so much about it in our wave propagation scenarios. We put in the receiver sensitivity of -180 dBm here. For the median signal strength we insert -105 dBm, which is what I measured in a distance of 1.2 km. And for the sigma we assume 5 dB. As a result, our coverage probability is more than 99%, which means that we have a really decent radio link for a field sensor application. For a moving sensor device, we would insert a sigma of about 9 dB, which yields then to about 92% coverage probability. This would be still an acceptable coverage to operate a sensor. For the received signal to noise ratio, or the so-called C/I, we can apply a similar logic. And then we can calculate the interference probability for our signal. Wave propagation prediction is a wide field given the broad frequency band where wireless communication is possible. The range can be from centimeters up to millions of kilometers. We covered here a part that is important for systems that we use in our daily life. Relevant scenarios were discussed and methods for the prediction of the field strength and the coverage probability were given. And of course, the prediction tools for the field strength and the coverage probability are ready for download. As usual, you can use them straight away, and in case you are interested, you can adjust them with your own experience to improve the accuracy. Here is a hint for the ones that want to dig deeper in this field. There is methods and tools available to compute wave propagation using topographic databases, land usage data, building databases, etc. Some of them are also considering reflection and diffraction effects. The computation methods are heuristic and deterministic ones. Even neural network methods are applied in this field. However, these tools tend to be expensive, they require a huge effort for the setup, and the calibration with measurements can take weeks for experts. Sometimes you can find also online services for wave propagation prediction. In any case, compared to that, the cost-benefit equation is really great for our tools, especially for hobbyists. And I have to say that even top experts are often using the given methods for a quick cross-check. In order to complete the subject, we need to talk about antennas and link budgets. A coming episode will cover this. Now, stay tuned and don't forget to subscribe and support the channel. See you soon in the coming episodes.